Hello and welcome to our presentation on our paper titled Learning about Social Context from Smartphone Data, Generalization across Countries and Daily Life Moments. This is a joint work with me, Aurel Mäder, Lakmal Meegahapola and Daniel Gatica-Perez. This project was realized in the context of Project WeNet. First, let me talk about our motivation. In this project, we tried to infer the social context of people giving their smartphone sensor data. We do that because we believe that human beings inherently need social interactions, community, and interpersonal relationship. By providing users with reports about their social context, we can help them to achieve their personal goals and to improve their mental health. Information about social context is especially useful in digital health applications, and we hope that with this project we might aid the development of such digital health applications. To summarize the prior work and research gap. Priorly, social context has already been inferred with smartphone sensor data in very specific situations. Meegahapola and others already did two papers where they inferred social context during either eating episodes or alcohol drinking episodes. In this paper, however, we do infer social context in general life moments. Social context has also already been inferred of very specific population cohorts. There are prior works on inferring social context of people who suffer from depression. However, in this work, we infer social context of data from general population cohorts. Lastly, the existing research inferred social context with very limited geographical data from one or at most two countries. In this work, however, we learn about social context with smartphone data in a general setting. We use smartphone sensor data from a very diverse set of countries. As you can see here on the left side, we work with data from Mongolia, Paraguay, Italy, Denmark, and the UK. And we infer social context in diverse daily life moments. To infer social context, we use smartphone sensor data such as, for example, Bluetooth usage, proximity, touch occurrences, Wi-Fi, or cellular usage. Now, our social context inference task is defined as inferring if somebody is alone or not alone. Based on this data and this setting, we are asking four research questions. Our first question is, what situational and behavioral contexts are associated with social context? We answered this question with a very broad data exploration and with a mixed effects model. The second question is, can social context be inferred with mobile sensor data? The third question is, can this social context inference be improved by partially personalizing models? And lastly, research question 4 is, do models generalize well to unseen countries? So if you train a model on a certain set of countries and then you deploy the model to a new country, how well does the model still perform? Now, our dataset is one of the largest smartphone sensing datasets collected to date, spanning 5 countries such as the UK, Denmark, Italy, Mongolia, and Paraguay. And it includes data from 581 university students who recorded their smartphone sensor data over 4 weeks and from 10 different sensors. The users recorded 292K activities and social contacts in their diary. If we look on the table on the bottom, we also see that depending on the country, the ratio of moments where users were alone or not alone varies broadly. So in the UK, users were mostly alone in 70% of all cases. However, in Mongolia, users were mostly with other people, so they were only alone in 25% of all cases. Now, our experimental setup is following. For research question 1, situational and behavioral aspects around social context, we did an extensive data exploration, and then we used a mixed effects model to identify the most indicative sensors of social context. This mixed effects model will be not presented in this presentation, but we invite you to read the paper, and then you can also see the results of this model. For research question 2, 3, and 4, where we inferred social context, we used 4 different machine learning models, such as a logit model, a random forest, a SIGCHI boost, a ADA boost model, and we used hyperparameter tuning and feature selection. We used a 10-fold cross-validation to calculate the mean AUC and F1 metrics, and we also calculate standard deviations. Now, to explore how well models perform across countries, we operationalized country diversity with the following experimental setup. We defined different training and testing settings. So, in the country-specific model, which is the first case on the very left, models were trained from data from one countries, and then they were tested on the data of the same country. Now, in the multi-country models, we use data from a set of countries to train the model, and then we tested the model on the same set of countries. Lastly, in the country-agnostic model, we use data from a set of countries to train the model. However, we tested the model on a new country. This emulates a situation where a model is first trained in a certain set of countries and then it's deployed to a new country. To answer research question 1, diverse daily life moments, we see very nicely in this plot that social context varies very strongly depending on the life moment you capture. So while studying, most of our users were alone. However, during eating episodes or in the household, most of our users were not alone. Now, to answer research question 2, how well social context can be inferred with smartphone sensor data. We trained and tested in the country-specific case a leave K user out model. So we trained our model on n-k users and tested the model on the caved user, which was not in the training set. This emulates a case where a user starts using the application for the first time. Now, we see that in the country-specific case, our model performs around 67% AUC in the case of UK, Denmark, and Italy. However, the models perform up to 75% AUC in Paraguay and Mongolia. Comparatively to the general multi-country model, which performs at around 68% AUC. To answer research question 3, we trained and tested our model in the leave K user approach, and we compared them to partially personalized models, meaning in those models we used some data of the individuals to enrich the model, and then we see that personalization really aids the models greatly. So personalized models greatly improve with performance gains in the range from 20 to 30% AUC. So you really see that social context is a very personal and individual phenomena, meaning that it really needs data from the individuals to perform well in this inference task. Now, to answer research question 4, the last research question, how well models are generalizable to new countries. we can look at this plot, and here we see that models don't perform very well in countries which they never saw before. So if we look at the country-specific models, they are always some percentages better than the country-agnostic models, which did not have any data from the specific country they are tested on in the training. And especially in countries such as Paraguay and Mongolia, we see that there are huge improvements in the AUC of the models if you have data from the specific country. So, a model in Mongolia, for example, performs without data from Mongolia only around 63% AUC. However, if you give it data from Mongolia, it performs up to 75% AUC, which is an improvement of 12%. To conclude our paper, one very interesting thing we noted is that in the case of social context inference, we do not observe good generalization of models across countries. Instead, we observe very poor generalization of models, even or regardless of geographical or cultural proximity, meaning that even models which are trained in the UK or Denmark do not perform very well in Italy. This is very interesting, especially if you compare our work to prior work which was also done by Meegahapola and others in the context of Project WeNet, where they saw that models generalize very well. However, we see that our models, our social context inference models, do not generalize well across cultural or geographical close countries. Thank you very much for your attention, and we invite you all to read our paper if you are interested in further analysis and more results. Thank you.